everyone, and welcome to the 25th episode of PEEPanEIP, the one and only EIP focused series where we discuss an Ethereum improvement proposal and understand how it is going to make the Ethereum chain even better. I'm your host, Pooja Ranjan, and with me is William Schwab, Brent, Alsop, and Alita Moore from the Ethereum cat herders. Wow, it feels so good that we are 24 episodes old. To me, it's like we just started. Nevertheless, if you have missed any proposal that we discussed in earlier episodes, you may follow the recording available on PEEPanEIP playlist on Ethereum Cat Herders YouTube. Today, we are going to have an overview of EIP-2315, simple subroutine for the EVM that is created in October 2019 and is a standard track core EIP that is in draft status. It is also up for Berlin upgrade. To provide an overview, we have got with us Greg Colvin, one of the co-authors of the proposal, who happens to be on our show multiple times as an editor. Welcome again, Greg. It's always been a pleasure to have you on the show. This time it's a little different that we would be talking about a proposal. And of course, if time permits, we will hear your thoughts on new standardization process, network upgrade, and other things as an EIP editor. So without further delay, the floor is all yours.
I'm broadcasting from a hotel room in Huntington, West Virginia, because everyone's heard of the big storm in Texas, but a little place called Boyd County, Kentucky got hit as hard or harder. And I've been a refugee for almost 2 weeks now. So finally they cut a route into our home Monday, and we got there and there was power, but no internet, no telephone. So I've rented a room here where I have internet. So join this meeting and start to get some work done again. So glad to be here. I've lost track of the process. This is labeled draft. I looked at the other EIPs going into Berlin, and I think they're all in a different status. So clearly we haven't gone back through things and labeled them with whatever the new labels are. But I think they must all be close to final or they wouldn't be going in. So this one's basically done. Code's written, it's in the clients. Nobody expects any changes at this point. It passes all of its test cases. And that's been true since June. So we're just waiting out the seemingly endless delays of Berlin. I'm a bit frustrated because it's just such a simple proposal, but harder things are pushing it down the road. And someday we'll learn to turn releases over faster than monster corporations with hundreds of programmers trying to coordinate. But that's a core dev frustration. We're getting there. This particular proposal actually has a long history going back to EIP-615, which was basically an attempt to get the EVM up to the standards of the JVM or WASM, a more structured assembly code that assured certain safety properties. And that was just too big an ask. I don't entirely understand why, but it was just a lot of work for the clients who seemed like it. And eventually that was set aside. And this is a much simpler proposal to just get a bare mechanism in for doing subroutine calls without a lot of effort, as opposed to a more complex proposal that made sure that you had to use the subroutines correctly. You couldn't underflow the stack, and other safety properties would be nice. One of the hangups there is there needed to be a mechanism for doing versioning on EVM. The original EVM did not reserve an opcode, or something to put at the beginning of the code to say, this is version 1, this is version 2. And that turned out to be difficult enough to do that it still hasn't been done. And it'll take a lot of motivation if it's easily doable at all. I'll screen share briefly. Let's hope this works. Hello. Okay, I'm trying to share a screen, but I have, there we go. Is the screen visible? Okay.
Yeah, it is.
This is a little snippet of Solidity code. Just two functions, one calls the other. That couldn't be very much simpler. On the left is what Solidity currently has to do to call out from the test small function into the multiply function. It's not pretty. And I don't even want to try to explain what it's doing because I've never tried to figure out what it's doing. But mostly the problem is that it has to use a dynamic jump and function, a dynamic jump to emulate the subroutine call. So it's got to get arguments to the jump on the stack as well as the arguments to the subroutine. And then it has to go through a lot of work to swap things around on its way in and on its way out. On the right is what you do with the 2315 proposal. We've introduced a begin sub opcode that says this is the beginning of the subroutine. We've introduced a jump sub opcode that says you push the address of a routine and then you jump to it. And we've introduced a return sub which says, I'm done with this, please return. So we have a multiply, which has a begin sub to mark its beginning, has a mul instruction to multiply what's on the stack, and a return sub to mark what's on the stack. And here is an example of actually using the routine. So you start out, you want to multiply 2 times 3. So you push 2, you push the multiply address, and you jump to it. So here you've pushed a 2, you've pushed, I got that backwards. Anyway, the stack's running the other way. That's right, it grows down, it's right. You push the 3, you've got a 2 and a 3 to multiply. Then you push, the multiplies popped off the stack. You have a 2 and a 3 on the stack. You implement the multiply, and there's a 6 on the stack, and you return. So a huge saving in the complexity of the code and a huge saving in the amount of gas you have to spend to call a subroutine. And that's pretty much all there is to it. And the EIP is longer because there's more detail and there's test cases for most of the ways to do it right and to do it wrong. But there's just so very little to say about it because it's just that simple. The difference here from 615 is there's no error checking. You can do these in any way you want. You can make all kinds of messes. You could actually do an ordinary jump right into the middle of the multiply routine. It's not entirely clear what would happen, but you're on your own with that. So you could do things like implement subroutines with multiple entry points. which is supposed to be a very naughty thing to do. But if you want to do it, you can do it. And it's your problem not to shoot yourself in the foot. I preferred that the code be verifiably correct, but this is a much easier thing to get into the interpreters. On the TurboDef project, there's some people doing static analysis, and a possibility that rather than restrict the EVM code to enforce safety properties, we can do a static analysis of the code when we deploy it, and the static analysis can prove that the code meets certain safety constraints, and then the proof can be attached to the code. So you'll have a certificate of the proof attached to the code, and then compilers, fancier interpreters can use that certificate to say, okay, for instance, they've proved that this program will never overflow the stack. Therefore, I don't need to check for stack overflow. They proved that this program follows the structured control flow. So when I compile it, I can assume that the control flow is structured, and other things like that, rather than guarantee that they're true through the EVM code, you prove it later. It's a more sophisticated technique, but actually much more flexible. We'll just see how that works out.
How does that flow from this EIP? As in the just maybe to specify that a bit more. You're saying, if I understood correctly, that introducing these opcodes enables certain kinds of static analysis or certain code guarantees. Oh no, incorrect.
No,
okay.
It doesn't. I was saying EIP-2315 constrained the bytecode to say that it had to meet certain properties up front, and provided opcodes to make it easy to do that and easy to verify up front when you first deployed the code that it met those properties, but only those properties. The concept that some of the TurboDef people are working on is to take arbitrary EVM code. They don't need this extension. Code that uses this extension well will make their life easier, but they don't need it. Take arbitrary bytecode, do a static analysis of that code to prove that the code has certain properties, and then attach proof to that code. And they're getting into black magic that I don't understand.
Do you know how these opcodes make it easier? Is it because they reduce the amount of code? Is it because it breaks it into separate structures with the jumps and the returns?
You look at the code on the left, and you've got a raw jump there. And in this code, the flat address of the multiply is pushed before the jump. So the analyzer can say, this code is going to jump to the multiply. It's only going to jump to multiply. But the jump code is dynamic. You could do a calculation of what subroutine you're going to jump to. And then a static analyzer might have to throw up its hands and say, I don't know where it's going to jump. I can't run the calculation myself. I'm doing it statically. I'm not running the program. So having subroutine jumps and using them makes it easier for a static analyzer to know when it sees a jump sub, that it always knows where it's going to go.
I understand.
It also means, I've heard people doing static analysis for various reasons tell me that it's difficult looking at Solidity code to know where the subroutines are. They have to go looking in the code for patterns like this that say, oh, this is the pattern of a subroutine call and return. And these patterns change a little bit with releases. They can be difficult to recognize, and it makes their life more difficult. If Solidity starts generating code like this, it's easy to scan the code and say, oh, here's the start of the subroutine. Oh, here's the end of the subroutine. Here's the start. Here's the end. So it gets much easier to parse the code for analysis purposes.
I understand what you're saying.
Static analysis covers, I mean, pretty much anything you can do with the code without actually running it. So that can be for the purposes of making sure it doesn't have errors, for the purposes of compiling it to machine code, for just many different purposes, more than I even know.
Interesting. You mentioned before that in this simpler version, the current EIP, so there's all kinds of quote naughty end quote things that you can do with the dynamic jumps. Does that introduce any new security concerns, new attack vectors by being able to manipulate the EVM directly with low level code?
I mean, if you introduce new instructions, you introduce new attack vectors. You can't help that.
Has there been an analysis of what kinds of new attacks might be open using?
It doesn't introduce any new kinds of attacks, since you can do with dynamic jumps anything you can do with begin sub. So yeah, you can do a multiply and then a jump here, and it's not really different than doing the direct jump and a multiply here. So it's not that you couldn't do the same attacks before. It's just you have more instructions to play with in constructing these attacks. And let me try to stop sharing the screen, because I think we've gone through enough of that. And I am back as a digital representation of a person again.
In general, are there specific concerns that apply to adding new EVM opcodes that I probably could have phrased that a little bit better. When adding an EVM opcode, what special concerns do people need to keep in mind?
The main ones are backward compatibility. We really don't like to introduce backward incompatibility. And these don't have any problems with that. They're new opcodes, and they don't conflict with anything else. And adding anything gives you new ways to write an attack. It also makes it possible to generate code that's simpler and less likely to have errors in it. So that's a reasonable balance. It means you've got to write a little bit more code in the client, but in this case, not very much. And being that they're very simple, the test suite is we think it's going to catch any problems. So we're pretty confident in this one.
Have you already come up with gas prices for these opcodes?
Yeah, I don't remember what they were. Martin Spende, made some measurements, and I think jump sub is pretty much the same expense as doing a jump, and return sub is a bit cheaper. Might be even cheaper than that. Begin sub doesn't cost anything at all. It just sits there, so I can jump this. So I guess it costs one.
So there's certainly, you mentioned before that one of the big pros, so to speak, in favor of the EIP are saving on gas costs by eliminating a lot of EVM steps in code. So, I mean, you're saying that there's also not going to be any, like, it's not going to be a massively more expensive opcode than previous opcodes.
Yeah, they are cheap opcodes, and you get to use 2 cheap opcodes instead of a much larger sequence of opcodes. So we're just going to add up more.
Cool.
So I'm a little bit confused on how this would work. Or specifically, you're adding an opcode that's not doing anything, but then it does the same functionality with less code. How does that work?
Well, the begin sub is pretty much like a jump test. It just marks a place that you're allowed to jump to. For a begin sub, you're allowed to jump to a subroutine. For a jump test, you're allowed to do ordinary jumps to those. We actually started out just using jump tests, which would be the simplest possible thing to do. But it was simpler for the interpreter, but it was simpler for the programmer to be able to see the difference between the beginning of a subroutine and just any other jump destination. So that opcode is essentially free, and then the jump sub and the return sub are pretty cheap.
Okay, and then how do you know what the address is for that subroutine?
If you're writing an assembly language, you just have to know. And if Solidity compiler is generating the code, so it knows where it put the subroutine.
Okay.
There's no magic to it. If you're writing an assembly and you insert some code in between, then all of the addresses moved, and you have to take account of that.
So is that kind of what you were talking about with it not being like verifiably correct?
No. The older 615 proposal introduced more opcodes. And I don't want to get into that in any detail. I would have had to have read it again this morning. But it essentially enforced a lot more structure. And it had opcodes for actually setting up stack frames, making it illegal to reference variables outside of your stack frame, and constraints like that, similar to what the JVM has, similar to what WASM has. And then when you deployed the code, you could more easily, given that structure, verify that people didn't try to address a variable outside of the current subroutine, didn't try to jump into the middle of a subroutine, or other things like that might cause problems.
That makes sense. Thank you.
So this proposal is just bare mechanism. There's a stack you can push addresses onto and jump to them, and the return stack, when you return, it pops that address off the stack and returns to it. So it's just bare mechanism, and it's up to the programmer to use it correctly.
So in terms of writing these codes, what difference did people find it in writing in Solidity and EVM assembly? I remember some discussion in Discord, I think it was Gitter, around the performance issue. Could you shed some light on that? Like, I'm curious to understand if this is normal to have these issues using different language, or was this this proposal specific?
I'll share the screen again. I mean, I think this screen, I think this example or something close to it showed up in the Gitter discussion. You know, that it's just either as an assembly language programmer or as a compiler writer, it's an awful lot easier to write the code on the right than it is to write the code on the left. And it's going to burn a lot less gas to run the code on the right than to run the code on the left. So it doesn't directly give you any more safety, except that it's much easier to get it right. And it clearly makes it faster and makes it use less gas. So that's all.
So this wasn't this proposal specific, it's in general, correct?
Pardon?
So in this saving on gas part, was this the proposal specific or it is just in general, like using EVM assembly language is easier than the Solidity?
Oh, I definitely wanted it to be cheaper. But partly just from a software structure point of view, it's nice if you can break the software down into fairly small subroutines that, you know, do a small thing and do it well. And if there's a lot of overhead for calling subroutines, people tend to write, you know, big, complicated subroutines and get them wrong.
So you did mention about EIP-615 subroutines and static jump for EVM, which was like this proposal was very much inspired by that. As you mentioned that this proposal may have been helping us to lift up some of the constraint, maybe more on the structure and the part. Do you think any other you know, advantage that we got with this proposal? I mean, during the implementation of the clients, any issues that you could mention?
It's going to complicate the yellow paper a little bit more than I would like. Actually, introducing begin sub adds a whole nother little section to the yellow paper that's almost the same as the specification of the jump routine, but not quite. So, but I guess making the yellow paper just a little bit more complicated is
Perhaps a drop in the bucket at this point.
I guess so. It's unfortunate, actually, but if you have to put the complexity somewhere, I guess that's the place to put it.
Yeah, especially for this proposal. I mean, like I have seen this proposal to be used as, you know, test example, Ethereum test EIP tutorial docs. So I believe this is like fairly simple, and if people who are interested to just try the run test could use this example to follow along.
The actual proposal, I think it took me about 2 days to design and write it initially when 615 failed. It's like, well, we need something. So given 615, extracting this wasn't hard. And over the course of a few months on and off, Martin and Axic and Christian and I refined a few things. And writing the full proposal took longer because we went to the effort of trying to define it all very clearly, include a complete set of test cases. Martin hit on a clever thing in Geth where the running the test case generates the output showing the test case running. So we're hoping other EIP writers will write their test cases as thoroughly, because a lot of them show up without any test cases.
Yeah, that's certainly interesting. I just want to mention one thing, like I see this proposal is not updated with all the clients implementation link. This is up for Berlin. So this is something that maybe we could do it with the help of PR to add the references of the clients. Even the TurboGet that you mentioned, that they are trying to do some experiment with the EVM codes. So yeah, I think that would be great for people to reach out to.
Yeah, I'm not sure if TurboGet is going to be ready for Berlin or not. I think it will be. I'm just not sure. You'd have to ask Alexi.
Yeah, right. But definitely we can mention the reference of the implementation in this client as well, right?
I'd say Geth is the reference implementation, as is so often the case. TurboGeth is just an alpha.
Right. I learned recently about the proposal that you were mentioning earlier, that it could be complementary to EIP-2315, which is not the proposal, of course, it's just an idea right now. Would you like to talk about it a little bit?
One of the hassles with using this is that if you have any local variables, you have to keep them on the stack. So you're more likely to hit the 1024 stack limit, and you still wind up with the limit of you can only get 16 locals onto the stack and still reach them with a dupe or a swap. And you've got the complexity of duping and swapping things around to get them where you need them. So it's more convenient in that sense to put them into memory, but then you have the inconvenience of keeping track of where did you put them in memory and clearing that memory out when you exit the routine. And Nick Johnson's suggested that we, in addition to the stack pointer, have a frame pointer, because a lot of languages and machines have the concept of a large frame of parameters and local variables. So that would let you keep in memory a frame of data as well as the stack pointer. And then as you move along, you move the stack pointer, you move the frame, you move the stack pointer, you move the frame. And as you go back up, it recovers the memory automatically. Nick points out that his mechanism is more general than that. So I called it an auxiliary stack, and he didn't like me calling it that. And I think I told him, well, it's Sunday afternoon, and there's a little girl here who wants to play. So we'll work out the language later. But it's, I think, a very good idea to let you build stacks in memory and not just on the EVM stack. And that gets you around this 1024 constraint. It gets you around having to work in complete 256-bit slots. You can save larger and smaller data structures using MStore. So, but he hasn't gotten to an EIP with it yet. And I'm going to be pushing him to do that.
Yeah, I think if I remember correctly, Nick briefly mentioned it when he was here with us on one of the earlier episodes. So
Yeah.
definitely looking forward to the proposal.
He discussed it a bit on the EVM graveyard channel in Discord, which wasn't quite where it belonged since it was a new idea rather than something we were trying to get rid of. But as these chat channels go, things just sort of come up, whether it's the right place or not. So.
So yeah, I have one last question about the EIP status. It's actually not a question. Like in the beginning of the call, we were discussing about the status of the proposal, right? So as you may have been familiar, that the standardization process that we are trying to enforce here with every proposal getting into upgrade or not an upgrade in standard as general. I think this proposal is definitely way ahead of the draft. So maybe it's a good time to change it to review and then to the last call, because I believe the final we have to wait for till it is deployed on the mainnet. But before that, at least we can move ahead with 2 stages.
Yeah, the way back when it was pretty much me and Nick and Hudson who worked out the initial scheme, and we were pretty much in the EIP scheme. Things became drafts and they stayed drafts. and then the core devs could do whatever they wanted with it. And if ever it hit the main chain, then whatever it was that actually hit the main chain would come back to the EIP process as final. Last call got introduced mainly for ERCs, so there'd be some process for saying this ERC is done. This is what you need to implement, and there'll only be errors on it after that. And in discussions over recent months, a more complex scheme has been put together. And I've been one of those, just goes, no, I don't really want a scheme like that. But given that exists, I'm not quite sure where it should be. There's no point in last call on this. It's done, it's implemented, it's tested, it's in the clients.
Yeah. But for the sake of the process, what we are suggesting, and we are trying to practice this with every proposal, like I have created a pull request to change it from draft to at least in review. Obviously, it is implemented, so it's not good in review status as well. And there is no fixed duration that it needs to be in that status. So once it is merged as a review, we can go ahead and create a pull request to keep it in last call. And we're going to keep it till it is deployed on the mainnet. Because in case something goes wrong and we have to make some smaller changes on the code. So we are just trying to be safer here, keeping it in last call till deployed. So yeah, I'll be happy to create
I'm pretty much done with it, I hope.
Yeah.
When I was volunteering, I had more time to do these things. And now that Alexi's actually paying me to work on TurboGeth and Silkworm, I don't have time for anything else.
No, I mean, it's always good to hear about your contribution that you have done so far. It's really a good work. I appreciate your hard work for them.
Thank you.
I think that's all the time we have got today. And I really appreciate you taking out time going through the proposal. It was really interesting to listen to this information. I wasn't even aware that last call was introduced for ERCs only. This is a good piece of information.
It bounced back and forth, but during the periods of time where core EIPs went through last call, then they went to the core devs and there wasn't another last call. But I really have lost track of the current stages.
Okay, thank you very much for coming to our show. And we hope to see you soon again with some or the other proposals or some advices.
Thank you.
On that note, for all our YouTube viewers, this was one of the 5 proposals going in the Berlin upgrade, which is expected to be on the testnet on 2nd week of March and on the mainnet around mid-April. You may find recordings of all other EIPs going in Berlin at the PEEPanEIP playlist at ECH YouTube. If you have any further question on any of these proposals or this episode particularly, you may leave your comment or ask the author. His Twitter handle is provided in the description section, along with the resources for this proposal. Do let us know how you like this episode and which EIP would you like to see in upcoming episodes. Your feedback is important to us. You can share your feedback and tag me at Pooja Ranjan19 or the Ethereum cat herders at cat herders on Twitter. Join the ECH Discord for latest on Ethereum network upgrade. Invite link is provided in the description below. Next week, we will have Eric Marks with us to talk about EIP-2315, wallet at Ethereum chain RPC method. So stay tuned for the upcoming episodes. Do hit like and share. Don't forget to subscribe. Keep sharing your love with Ethereum cat herders. This is all of us signing out.